All right, so it looks like we are done with the do now. And so we are on to this page. This page is literally a review of everything, every single topic, concept, idea, vocab word that has to do with similarity, and there are some specific study points here as well. When you are studying, you will need to study these topics. Dilation constructions, not so much. They don't come up. We don't really discuss them. I am probably not going to be injecting that into our lessons this summer since we have so little time. Okay? Scale drawings, sure, you have to know how to understand that scale drawings. To understand what the scale factor is, you take the image, divide it by the pre-image, and so on and so forth. You do need to study all these concepts, all of which are available in that blue book or the red one, whichever one you choose to go with. Vocab that you must know to be successful in terms of understanding similarity are all of these. If you have forgotten any of these concepts, you do need to review them on your own, okay? What we are going to be doing today and what the video lesson is going to look like today is simply completing the solutions to the even numbered questions in this packet. You're responsible for everything, even and odd. And so whatever you haven't recalled or remembered, it is up to you to use this time to go through your blue book, your Blue Barons book, or to look up the concepts on YouTube or whatever instructional video site you like to use and teach yourself these concepts, okay? Khan Academy is fine to use as well. You have to determine what concept goes with what question, or rather what question goes with what concept. Look it up, learn it, and so today is really an independent learning day, which is very effective for you guys. Okay, and for everybody. I learn best independently. A lot of people do. Some people need a teacher to teach them at all times. Some people don't. But in any event, today it is an independent learning day. So just take the bull by the horns and, you'll figure it out. Okay, so again, all the topics that you need to understand for similarity are here. For Unit 6 right triangles, which is also it's similarity based. Trigonometry, that's what you guys are going to be doing on Monday, okay? So this is, Okay, so these are vocabulary words that you must know. And then what's great is they give you some specific study points. So this sheet gives you some specific study points and just the concept of geometric mean. If you forgot about geometric mean, that's going to be one of those things you're going to need to look up in your Blue Barons book or on YouTube, okay? Type in geometric mean, because that's going to be the first question in this packet, okay? So study all this stuff as well. All this stuff is very important, okay? So what did I mean when I said this is going to be the first question in the packet? This is going to be the first question in the packet. It's a geometric mean question. And because I said I'm only going over the solutions to the even numbers, this is going to have to be one of those that you have to figure out on your own, okay? And again, use the resources I suggested. For the second one, this one right here, I started working through the problem, drew some ugly triangles, but made sense of it, okay? So it says, what I would suggest is you try this out on your own first, okay? This is a side splitter question, all right? It's definitely a side splitter. The only thing about this is that this triangle has been flipped, okay? So notice that it's kind of crooked in comparison with the big triangle. It doesn't look like these two sides are parallel. That's because if you flip this back over, it would be parallel. But this was flipped and it was meant to trick you, okay? So points T and O are on SU and SC respectively. Segment OT is drawn so that angle C is congruent to angle OTU, which is this right here. Then they give us the segment lengths, okay? Now the trick here is, keep in mind, these are similar triangles by angle-angle similarity. If you were to flip this triangle UTO back over, it would end up in a position where these two would be parallel to each other and it would look the way it's supposed to look. But that's not the case, all right? So, but what if I did flip it over? So now we have C, S, U, which is the big triangle, and again, angle, angle. They both have this angle U in common. I'm going to get rid of that. If I were to flip this over so that it looked the way it was supposed to look, T would be here, O would be here, and U would still be there. So, right, if I flipped it, that's how it would look so that these two would be parallel, okay? So now, because I flipped it, my TU is going to be here. My CO, well, that's 7. This whole thing is 12. 7 plus 5, right? So CU is 12. And then TU is 4. We said that. TU is 4. CU is 12. TU is 4. CU is 12. Okay? So it looks like these are corresponding sides. TU and CU correspond. And the reason why we know that is that just like if you take a look at where this angle is, like angle C right here, angle C, and angle O. In similar triangles, corresponding angles are directly opposite corresponding sides and vice versa. So I can determine what angle, and excuse me, this is wrong because they say T. It's T. I can determine what sides are corresponding based on the angles that are directly opposite. So whatever side is directly opposite angle C, which is SU, is going to be proportional or corresponding with whatever is directly opposite angle T because they're congruent. I repeat, whatever side is opposite this angle here is going to correspond to whatever side is opposite this angle here. Okay? So this is 4 plus x, right? So SU corresponds with OU, okay? All right, so the arrows are telling me everything. So I may have thought something before, but the arrows are telling me exactly what the deal is. So this side T, this angle T is directly opposite side OU, which is 5 units in length. This angle C is directly opposite side SU, which is 4 plus x units in length. Then I'm also given 12, this whole side 12, which is going to be proportional to this side right here, if I'm not mistaken. No, it's not. Nope, it is not. Okay, so this 12, and we're trying to find ST. We're trying to find this right here, okay? So we can set up a proportion based on what we have. We have, so these two sides are the corresponding sides, 5 over 4 plus x, right? So 5 over 4 plus x, and then these sides, side 12 and 4. So so 4 over 12. I'm going to redraw the diagrams for you. Maybe with a marker. Let's get a marker. Okay, so I actually had to get up and get some markers. So what we did initially, we have these two triangles. This one was flipped in a different way so that whereas we should have the T over here and the O over here so that these two are parallel, which they are, if you flip this back to the original position and the position it was supposed to be, your T would be here, okay? So your T corresponds with angle C. Angle T in the small triangle corresponds with angle C in the big triangle. When you have angles that are congruent to each other, corresponding congruent angles, the sides that are corresponding are directly opposite them. Okay, and therefore, when we set up our proportion, we had that. Okay, so that's why I put 5 over 4 plus x. But there's another set of corresponding sides. The other set of corresponding sides is this one right here. Side CU, which is 12 units in length, and that corresponds to side TU, okay, which is 4 units in length. All right, so therefore, that's how we got this other part of our proportion. So the 4 side TU, the side from the small triangle, over the corresponding side in the large triangle. And so then what we would need to do is solve it. Okay, so I'm going to rewrite it because you can't really see it with the highlighter. So I'm going to rewrite it as 5 over 4 plus x is equal to 4 over 12. And so we end up with 4 times 4 plus x is equal to 12 times 5, which is 60. Okay, and then from there, you just need to solve it. All right, so we end up with 16 plus 4x equals 60, minus 16 minus 16. 4x is equal to 60 minus 16, and that's 44. So x is equal to 11. Okay, so this is 11. All right, on to the next one because this video is getting very long. Okay, so number 4. It says identify congruent angles and write proportions for corresponding sides. So we have triangle ABC and we have triangle DEF. They are similar. All right, so identify congruent angles and write proportions for corresponding sides. So identify congruent angles. In similar triangles, angles are congruent. So angle D is congruent to angle A. Angle B is congruent to angle E. That's because they're in the same position. They are corresponding. And then angle C is congruent to angle E. Okay? Writing proportions for corresponding sides. Side AB over side DE would be equal to side, like if I took AB and put it over DE, it would, oh, this is an F. I don't know why this looks like an E. It would be proportional to side BC over side EF. And then extend it by saying side AC over side DF, okay? So AB corresponds with DE, BC corresponds with EF, AC corresponds with DF, okay? Number 6 in the accompanying diagram, triangle IHJ is similar to LKJ. If IH is 5, HJ is 2, and LK is 7, find KJ. So we have these two similar right triangles, okay? And we need to find the measure of this side right here, all right? Well, I notice we have two 90-degree angles, and then we have a set of vertical angles, okay? And so, as we know, these two sides are going to be proportional to each other because they're opposite congruent angles. So if IH is 5, HJ is 2, and LK is 7, then I can set up a proportion to find JK. The proportion I would set up is 5 over 7 is equal to 2 over x. 5 over 7 is equal to 2 JH over, oh, what sides are proportional to each other? Okay. Oh, this one is a little bit more interesting because this side is corresponding to that side. This is 90 degrees. That side corresponds to that side. And then this side corresponds to this side. So it actually is probably going to be fine. So 5 over 7, 5 over 7, So typically this is a different situation, maybe because it's 90 degrees. This side would be, would correspond with this side. So in vertical angles, that's usually the case. But looks like we're going to end up having a decimal, which is fine. All right, 14 is equal to 5x. 14 divided by 5 is equal to 2.8. X is equal to 2.8. Okay. All right, number 8. And actually, I'm going to skip number 8 and have you guys do that on your own. I'm going to go over one more, and that's going to be it. Okay. And then you'll do the rest on your own, including the proof. The proof you'll be able to do on your own. So I don't keep this video too long. Actually, let's do the proof together because I feel like this one should be fine. Okay, so number 12 says given RQP and RTS are right triangles, prove that these are similar. So you prove similarity with 2 sets of proportional sides and a set of congruent angles, 2 sets of congruent angles, or 3 sets of proportional sides. Here's a quick trick. If they do not give you any angle measured, if they do not give you any side lengths, you cannot use this, nor can you use that. If you don't see a fraction, if you don't see anything about proportionality, you cannot use either of these. So 99.9 times out of 10, or out of 100, you're going to be using that if they don't give you any information about the side lengths, okay? So let's have our statements, our reasons. The first thing they tell you is that these are right angles. All right, so right angles oh, this is given. As you can see, I'm off because I'm kind of in a rush because I don't want this video to be for 20 minutes long, but it's looking like it's getting there. Okay, angle RQP and RTS are right angles. Okay, that's given. So angle RQP is congruent to RTS. Right angles are congruent. 3, we have vertical and a vertical. Angle QRP is congruent to angle SRT. Okay, and vertical angles are congruent. PQR is similar to STR by angle-angle similarity criteria. Okay, and that's that. The rest you will do on your own. and seek assistance where you can get it. Use the resources I told you to. Bye.